Hey guys, it's Leia. Today we will talk about how to solve logarithmic inequalities. First, we will learn how to solve logarithmic inequalities in a form like this, where a and b are numbers and the inequality sign can be any inequality sign. In order to solve them, first isolate the logarithmic expression. Next, we write b such that b equals log base a of a to the power of b, or b equals ln of e to the power of b, depending on the inequality. Next, based on the value of a and the inequality sign, we pick one of these rules. For when a is greater than 1, the following rule can be changed for any inequality sign between log base a of f of x and log base a of g of x. Just change the inequality sign between f of x and g of x to match. Our final step is to solve the inequality from step 3. If b in the original inequality is already written in logarithmic form with base a, we skip step 2 and move on to step 3. Let's see two examples of this. First, we have log base 3 of x plus 2 plus 1 is less than 5. First, we isolate the logarithmic expression. So we subtract 1 from each side and get log base 3 of x plus 2 is less than 4. Next, we rewrite b such that b equals log base a of a to the power of b. In this case, b equals 4. So 4 equals log base 3 of 3 to the power of 4. And then we plug this back into the inequality. Next, we use this inequality. Since a is greater than 1, log base 3 of x plus 2 is less than log base 3 of 3 to the power of 4 is equivalent to x plus 2 is less than 3 to the power of 4, and x plus 2 is greater than 0. Finally, we solve the inequality from step 3. First, we will solve x plus 2 is less than 3 to the power of 4. We subtract 2 from each side and get x is less than 79. Next, we solve x plus 2 is greater than 0. We subtract 2 from each side and get x is greater than negative 2. So we have x is less than 79 and x is greater than negative 2. We combine the ranges and get negative 2 is less than x, which is less than 79, our answer. Last example, we have log base 0.23 of 2x plus 1 is greater than 4. First, we isolate the logarithmic expression. This is already done, so we can move on to the next step. Next, we rewrite b such that b is a logarithmic term. In this case, b equals 4. So we have 4 equals log base 0.23 of 0.23 to the 4th. Now we can substitute this into the inequality for 4. Since a equals 0.23, a is greater than 0 and less than 1. So we use this identity. We have that our logarithmic inequality is equivalent to 2x plus 1 is less than 0.23 to the 4th, and 2x plus 1 is greater than 0. Finally, we solve this inequality. First, we solve 2x plus 1 is less than 0.23 to the 4th, and get x is less than 0.23 to the 4th minus 1 over 2. Next, we solve 2x plus 1 is greater than 0, and we get that x is greater than negative 1/2. We combine the ranges and get negative 1/2 is less than x, which is less than 0.23 to the 4th minus 1 over 2, which is our answer. Now we will learn how to solve an inequality in this form, where a and b are numbers. In order to solve it, first isolate the logarithmic expression, which is in the form a to the power of log base a of f of x. Next, we use this very helpful identity to rewrite the inequality. Finally, we solve the compound inequality made up of the inequality from step 2 and f of x is greater than 0. Not too complicated, so let's see one example. Here's our example. We have 4 to the power of log base 4 of 5x plus 1 is less than or equal to 6. First, we isolate the logarithmic expression. This is already done, so we can move on to the next step. Next, we use this identity to rewrite the logarithmic expression. So 4 to the power of log base 4 of 5x plus 1 is equal to 5x plus 1. So we replace the logarithmic expression with 5x plus 1 and get 5x plus 1 is less than or equal to 6. Finally, we solve the compound inequality. 5x plus 1 is less than or equal to 6, and 5x plus 1 is greater than 0. We first solve 5x plus 1 is less than or equal to 6. We get x is less than or equal to 1. Next, we solve 5x plus 1 is greater than 0. We get x is greater than negative 1/5. So we have x is less than or equal to 1 and x is greater than negative 1/5. We simplify and get negative 1/5 is less than x, which is less than or equal to 1, our answer. Solving logarithmic inequalities can be tricky. However, if you keep practicing these problems, you will become much better at them. Visit www.symbolab.com and click on the Practice tab for more help or practice.